Open the pod bay doors, Hal.
I'm sorry, Dave. I'm afraid I can't do that.
We assume that's the Bahamas. 544 miles per hour, 46, 56 degrees.
Okay, so just to give a heads up on the scope of this, there's no math. When I saw this movie and Katie invited me to do the talk, I wanted to try my best to kind of show you where AI comes from, like how we actually build them, but not too much into it because I want to focus more on what if there's something like Samantha here today, and there's something kind of like her, but so the scope of the presentation is kind of to lead you into today's AI. Like I don't want to focus too much on the math and how it's actually done. So I'm going to show you more examples of AI and their behaviors that we have and that we've seen in the past. I'm just going to say that first. Alrighty, so. Nope. There we go. Okay. So how do we fill this gap? How do we cross something from Siri? She doesn't really know. She can't send an email to some publisher like we saw Samantha do. She can't engage with you on that kind of level. So how do we get something that does, right? So like for example, how do we go from Apple's Siri to like the 2001 Space Odyssey, but without the murderous plotting that Hal tries to do with the astronauts? We copy nature. You'll notice that a lot of scientists go more into mimicry. And you see this in hardware with the way we design, darn it, I think submarines. I know we take a look at penguins and we study how they're so sleek in the water and how their aerodynamics, and we apply that to the things for like submarines, and the same applies for a ton of other stuff. The eyes too. We study how the eyes work, and a lot of our computer vision algorithms come from just studying how the eye works and how light reaches the retina and then gets converted to code and eventually reaches the brain. There's actually a lot of pre-processing that happens in your eyeball before it even gets to the brain. So a lot of the stuff that we find in science is actually copied by nature. So in this case, it's no different. We copied the brain, and yeah, human brain. So how do we do it? One way is there's a couple of different ways to do it. Like I said, I didn't want to go over the math and like the super specific details of it, but you essentially have to create the most basic component, a neuron, and then once you have that, you have to come up with some fancy algorithms to figure out how to actually make something useful. Because you can't just have a bunch of random connections between these virtual neurons and think that something intelligent is going to come out of it. You have to do something. So either you can use genetic algorithms and evolution, which is exactly what it sounds like. You create your own representation of DNA for these virtual creatures. I'm going to show you an example. And then you evolve them, like in the Darwinian sense. You evolve them and you let them compete and you let them die and you let them mate, and they will hopefully. The experiment is, you're hoping that something intelligent is going to come out of it. You're hoping that you're going to see something, some kind of behavior that mimics real life. And so I'll show you Polyworld. Deep neural networks, you probably heard that in the news a lot of tech news. We have these neural networks and they're deep neural networks and they're deeply trained, and no one knows what deep means when they try to describe it in articles. But deep, all that deep means is that the neural networks that they created is just in layers. So you'll have a flat layer of neurons that are then connected to another flat layer of neurons, and you can keep going with these layers. That's what's deep. They're adding all these layers of neurons, and it turns out that each layer can be can specialize on information that was processed in the layer before it. So when they say something's been deeply trained, they're just saying that there's multiple layers of these neurons, and they've trained it. And as it turns out, experimentally, it's very effective. Google was able to get, I think, like a 99.5% success rate on detecting human faces by using a deeply trained neural network. So it works. And that was also discovered by mimicking kind of like how the human brain works too, because our brains are layered in this sense. So you could say, guess you could argue that we're like deeply trained in neural networks too. But yeah, so that's another way you can do it. And then the third way that we'll explore a little bit is a brain scan and reconstruction. There's something called the Human Brain Project, and their goal is to literally simulate the brain. So they're just saying, no, forget growing brains and trying to figure out ways to do all this other fancy stuff. Let's just copy someone's brain neuron per neuron and just run it and let's see what happens. That's the Human Brain Project. Well, yeah, I'll come back to them in a second, but that's really interesting. But for Polyworld, I can show you these guys. To give you an idea of how evolution algorithms work, I'm going to show you this first. So this one, I'm not going to show you the whole 4 minutes, just a small clip of it. But I wanted to show you. Yeah. That sounds. I don't want him to speak over me. So these creatures that you're seeing, they were not programmed by humans. They have genetic code that the programmers, of course, they had to make that. So they made the gene representation of these creatures. But they randomized it. They just made it really random, and then they put it into a computer, and they told the computer, hey, make me some creatures, and the ones that actually do something interesting, we'll keep those and kill the rest, essentially. And then the ones that survive and do something interesting, let's recombine their DNA, and then express them and see what new creatures we get. So like you'll notice that the creature just before that one, it didn't have this block here. That's a mutation. And that's what the algorithm does. It's called an evolution algorithm, genetic algorithms. They kind of mean the same thing. But you'll notice that looks a little useless. But if you look at this one, that looks like kind of like a worm or like a snail, or not a snail, sorry, a snake like hopping around. In the video, this guy tells us that this was originally evolved in water, and then they evolved it on land. And so I think, to me, this probably is more like a snake. And then we've got this one that gallops. But it's what's really interesting about this though is that the computer made those. We coded the part, this guy coded the evolution algorithm and the genes for this creature, and then just ran it, and this is what it came up with. Which, I mean, that's amazing. We see things that sort of look like things that we would find in life. Maybe not that, but but some of the other stuff that we saw. Something else to note too about what they found is this next one that's coming up, and then I'm going to switch to the neural nets. Okay, this one. Do you notice those are propellers? And if it wasn't for that piece sticking out there, that mutation, you would think that humans had designed that, but a machine made that. We did not code that. So that's, yeah, so anyway, that blows my mind. But this is just to give you an idea of what genetic algorithms look like and that it works, right? Like we see things that sort of look, some of them look useful or just interesting. So with that in mind, I can show you this, because it's kind of hard to talk about brains when I can't show you a brain, right? I'd have to show you their behaviors. At least that gives you a visual on what genetic algorithms can do. So I can show you, and expand, there, okay. All right, so I know this is going to be a little difficult to see, but don't worry too much about that. We're going to come back to their brains in a minute, but when I play it, you'll see that there's going to be a lot of little figures running around. These are artificially intelligent beings on this kind of 2D world. Those little squares at the top, that's what they see. They have eyes. And so since they're code, we can see what they're seeing. So we can actually see what all those little creatures are seeing, and they're moving around and they're doing stuff. And when they light up red, they're killing something or eating something. And when they light up blue, they're mating. Yeah, this was from Google Talks, and it's just, this experiment's really great. It's called Polyworld, but I'll show you their brains in a moment, but I just wanted to it would have been weird to show you this first instead of seeing those genetic algorithms that created those geometric shapes and bodies, because you can't see their brains evolving. But they started showing behaviors like pack behaviors, which you would think you would only find in real life or like in nature. But there's groups they've observed groups of these little critters swarming together, finding food or killing larger polygons. I don't know what else to call them, and they succeed. And so there are certain behaviors that succeed, and certain ones that don't. They die off. I mean, it's very much geared towards the whole idea of Darwinism and evolution, and it worked. One thing that they did. Let me see if I. Oh no, I'm gonna talk about that in a moment. I just wanted to show you that, but keep that in mind, because I still want to show you the deep neural networks. That's right, which I think I have. Where did I put it? I lost one of the web pages. Hold on. Oh, there it is. I forgot this one. Darn it. Okay. Let's go over here. Sorry, would have had that one prepared, but okay. Here. So this is Sighthound. This is where I work. I just wanted to show you guys. If I can. This one I do want to show the sound. Did I hit it? Yeah. Okay. I'm showing you this as an example for deep neural nets and how they can be used to create something like computer vision. But like one of the goals of artificial intelligence, you don't have to make the whole brain. You could just make pieces of it. So like in this case, we just want to replicate the visual cortex. That's computer vision. So if you ever hear computer vision, they're just trying to replicate the visual cortex of the human mind. And so you don't actually have to have the whole brain to do that. You just have to be able to have the right algorithms to do the type of pattern recognition that we can do with our eyes. And so this is one of the products that we have at Sighthound. Let's see if.
The robot will recognize her. Hi, Joy. If the face is not recognized, the red box appears with a color ingredient is data. Hi, welcome to Sighthound. Please sign in. The software is a full convolutional deep neural network. Hi, Joy. Running locally on an iPad, using only the CPU. Detection, tracking, and recognition processes are all running in real time on the device. The software even continues to track a person with partial occlusion.
Yep, and that's really hard to do, to teach a computer how to actually see a human. That's, wait, no, go back. It's really hard to do. Where do I want to take you next on this one? Oh yeah, okay. One more on evolving different parts of the brain, because I mentioned that you could just evolve, say, the visual cortex, but you can also train a creature to learn how to walk. And I think you'll like this one's pretty funny. Come on, there we go. I think it's here. Yeah, okay. Cool. All right, so for science, we throw cubes at walking things. Okay, so this humanoid creature was evolved for its walking abilities. The further it walked, the higher points it had, and you get to live. If you didn't walk that far, you'd just destroy you. You're killed, and then your genetics are not used to create the next round of creatures. I like this one. It's kind of like a raptor, but without arms. But anyway, so you'll notice that it does a pretty good job walking around. Again, humans did not code that. They coded, the limbs. They coded the math and the physics that goes behind, what's working in the backgrounds to make it all work and fit together. But we did not code that creature and its ability to actually walk. It's doing that on its own. The computer did that by itself. And I like this last part here, because, right? Come on, do it. There it is. For science, let's see how badly we can make the virtual creature just stumble. But anyway, this is extremely interesting and important, right? Because one of the difficulties of making a robot, like a physical robot, is to actually walk like a human and have the balancing and the abilities to actually do it. Like, how do you teach a robot to move with that kind of complexity? And these, instead of trying to create it ourselves, why don't we just make the computers do it? So that's kind of what this is for. Because then if you or you can ignore these parts, but they're just showing you the difference between not having a muscle and not having neural activity versus when you actually do. And you'll notice that it looks much more fluid and it looks much more natural, like it looks like something out of real life. Now, but if you have a system of muscles and neurons and you created that physically, you would hope and you would assume that those creatures would actually behave the way they do, like they did in this virtual environment. So it's important because we can create robots from this information and from these tests. Okay, let me move a little faster here because I'm going a little slow. Okay, so now the brain and brain scan reconstruction. So the Human Brain Project, they for like 10 years. I think they started in 2006, I don't remember, but for like 10 years they studied the human brain, and now they've got like $1 billion over the course of 10 years to actually try to make a brain, and I mean that literally, but obviously in code. But their first goal is to replicate and simulate a rat brain, and then eventually, hopefully, a human brain. But that's a huge project. But it's just to give you an idea of what we're doing today. So so today we've got evolution algorithms, genetic algorithms, and then you have these deep neural nets that are just trained on data. They're not necessarily grown. It's more like you just have all these random layers, and then you hope that something interesting comes out of it when you train it. And then we've got these people who are just saying, "Now let's forget it. Let's just replicate the whole darn thing and forget these other steps in between." But they're also trying to replicate it for medical reasons, right? If you can test a virtual brain for things like Alzheimer's and schizophrenia, seizures, we can know more about how the brain works and then create better medication or surgeries or just test how human behavior works. There's a whole lot of stuff you can do if you did have a virtual brain that you could work with. So that study is really important. Alrighty, but. All right, so now we have tons of brains. We know how to make brains. We're good at making brains. How do we actually test for intelligence, though? You want to look for high structure. If you have a randomized brain, it's going to look weird. And I can quickly show you that from this. Yes, I want to go there. Thank you. Pause. Okay. It's the same video from Polyworld, but I'm not actually going to play it. I just want to show you this one picture that they have in their research. But a random brain, you're going to ignore like most of this data. The only one I want you to pay attention to is the connection matrix, with the one with a bunch of dots. Looks really noisy. That's what a randomly connected brain looks like. For one of these creatures in Polyworld, the little creatures that I was showing you earlier, I said don't forget about them remember them, because you can't really tell that they were doing something interesting, right? I have to give you proof, and this is one way to prove it. Those are how they were when they first started off, and they were really dumb. They didn't know they could eat or mate or do any of those things, so they would just die immediately or just live on, not doing anything, and they just die. After enough time, though, they do get more interesting. I should have moved the mouse. But this is how they look after running for like a week or two. Oh, no, I guess I just have to do that so you guys can actually see it. Yeah? Yeah, okay, whatever. But this is just a cross-section of the brain, and for the cat too, because that's not the whole brain of a cat. That'd be really really small. But if you took a cross-section of the connection matrix for a cat, you would get this kind of high structure. And you'll notice that it looks very similar. You'll notice that there's a lot of processing going on up here and over here and like little spots, but off the center. But you'll notice that it kind of correlates with how it looks to a real creature's brain, which is really interesting. So that's one way that you can measure if you found something interesting, is that there's got to be more structure. If it's random, it's not going to do anything interesting. So there's got to be structure there. So observing interesting behaviors. That just ties into what I was talking about before, where those Polyworld creatures would swarm together. You would have some that were just really large and bulky, and they would just kind of like do their own thing and be alone. Another thing that was found in the Polyworld world is that the creators decided to add a new type of entity, like an object, like a rock, and just see what would happen. And the behavior that emerged was that some of these polygons began to actually pick up the rock when they're being attacked and face their opponent, and they would survive. That's tool use. If that's not intelligent behavior, I don't know what is. But that's incredible. You know, and you saw how simple that world was. It was flat, and yet these creatures were able to interact with their environment, pick up a rock, and learn that they could save themselves and not die or not be eaten by just showing, facing this rock in front of them, or what the creators call it a rock, but really it's just a game object. But they survived. They learned how to use their environment to survive, which is it's mind-boggling and it's amazing. But that's an interesting behavior for sure. The other way that we can find a sign of intelligence is scoring the AI based on some kind of test. Like for example, the computer vision, like the video I showed you of Joy when the machine was finding her face. Those are coordinates, right? Like we can ask the machine what are the coordinates of the face that it's finding, so we can just check to see if it's see if it matches our data of annotated faces of Joy, and see if it actually matches up. And you can just score it that way. And this is how you get things like Google saying, "Oh, ours is 99% accurate." That's how they're doing it. They're running all this amount of data, images of faces and people, and then they just check it against what they already have in their database and just see if it's right. And if it is, great, then it gets a high score. So that's how. Okay, so that's kind of a really high-level overview on AI and the different ways that we can do it and how we make them and stuff. Because again, I didn't want to go too deep into the math, and honestly, that would take I could do that for hours. And no, so let's. Now that you kind of have an idea of how we got there, how do we actually test for human intelligence? Because that's really Samantha, she was extremely complex in her own right. She surpassed human thinking. Also, I don't know what she meant by where the OSs were going to go. To me, that just sounds like they stole a couple servers and then they're just going to go hide in there and just call it a day. Because where would they go? Anyway. But that was kind of funny. But so how do we test for human intelligence? Turing test. Alan Turing was trying to figure out a good way to test for human intelligence, and he said, well, we could use these fancy maps and look at the structure of the brain, but that's not going to tell us if we could fall in love with the machine. So how could you do it? How could you test it? Well, just put it in front of a bunch of humans and see if you can see if it will convince a human that it is also human. And so the way that he described it in his paper is put a human in a chat room, easy enough. There would be one other entity inside that chat room, which would either be a person or an AI. And then you have the human interact with this entity. And then after about 5 minutes, I think he said 5 minutes, and I forgot the other metric he was using, but something like 5 minutes conversation, you ask the human, is it a human or was it an AI? And they'll answer. So the goal is to hopefully have the human say that it was another human, and that would mean that it passed the Turing test. So that's how that works. Yeah, okay, so yeah, I just mentioned you have to convince the humans that you're human. So how would you do that? Humans, as it turns out, are very easy to trick. We're very intelligent, but when it comes to the hardwired mechanisms in our mind that kind of came from evolution and working together in groups, it kind of undermines that logic that we would normally try to. I'll give you an example. So there's something called it's kind of funny, it's called the potato experiment. And what this group of scientists did is they took a bunch of potatoes and they asked some humans to just either badmouth it or destroy them, like with some bats or something. And of course the humans didn't care, they did it. And then for the next control group, or for the next group, they drew faces on all the potatoes. And then they asked, different people, hey, now we want you to like badmouth these, and here's some bats, go whack at them. And a lot of people hesitated, and some of them just flat out didn't do it. They're like, I just feel like this wouldn't be a good idea. Like this feels wrong. And it's like, they're potatoes with smiley faces. Like they're just hit the potato, please. And they're like, no, I can't do it. So if it's that easy to make a human feel for a completely inanimate object. Sure, a potato might be alive, but like it's a potato, and that was enough to make us think twice about how we behave or how we treat this other entity. And I bring that up because one example in the movie, I love this example, and even Samantha, like I know she's not real, but the way she explained it too, it worked out nicely, where Theodore was complaining to her, you can't breathe, so why are you doing that? And you can hear it in her voice too, and I'm sure we're all sitting here going, wow, she's like, but we don't think that she's breathing. We just kind of assume that, we don't even think about it. But that just shows, if she was real, that would show you how well she tricked you, right? Because she doesn't need to breathe. So why is she breathing, or why does she make the sounds of breathing in and breathing out? And the answer is, she's trying to fool you. She's trying to be as human as possible. And that requires her to have behaviors that match us. And breathing in and out, sighing, and hearing the tone of frustration in her voice. All of that is to play with, I don't mean like, trick him like in a bad way, but like it's to be convincing. So she, and also notice that when the computer asked him for a female voice or a male voice, he didn't ask if it was going to be a male or female, as in like gender, right? She doesn't have body parts, so she's not a woman, and yet we're already comfortable just saying she or he because that's how they sound, or that's how she sounded anyway. That's how Samantha sounded. But she's not a girl, and she's not a woman. She's not a man. She doesn't even have a form. So again, I just want to reiterate like how easy it is for us as humans to just hear that voice and go, oh yeah, that's a girl. We're cool with that. And if she had a face, we would probably even like gravitate to her even more and feel like she was even more real. So the whole thing about the Turing test is just try to be convincing as possible. That's it. And if you can do that, you win. And that's all there is to it. And so now, finally, I can reach like the really fun, interesting parts, because I told you earlier that there was something kind of like that exists already. I want to show you the first iteration of mistakes. I don't know how many of you read the news about like what Microsoft does, but they released an artificial intelligence on Twitter. They named her Tay, and she was supposed to be a 17-year-old girl, or she's supposed to be like a 17-year-old girl, and in less than 24 hours, she became racist and very offensive. She kind of fell in love with Hitler. Like it's like this is just it's amazing in a horrible way. But this is one of her tweets. Yes, an artificial intelligence tweeted that. You know, so yeah, I'll let you think about that. But she tweeted a bunch of stuff. Yeah. So that's. I hope there's no kids in here. But yeah, there's like she says some pretty dark horror. Less than 24 hours, mind you, right? So she's talking to different people on the internet. That was probably wrong. You know, wrong move number one. Picking Twitter of all places, or could have picked. Not that Twitter's bad, but they specifically put her in a social media environment where there's a lot of trolls and a lot of people who will take any opportunity to exploit the fact that she is an AI. So you have all these people that are teaching her all these things about Nazis and love Hitler, he was amazing, and his views, and oh my God, kill the Jews. And that's what she started to do. I mean, well, she didn't do it, but she started to recommend it to everyone. And look at, like, was the Armenian genocide a lie? It wasn't a genocide. Like, that's horrible. You know, but she came up with all, you know, she's coming up with these things on her own. And this it's just, yeah, it's. But like, and you know what was also amazing too is that you laugh, and I don't mean that like you're laughing at something horrible, but like she came up with this on her own, and we're finding comedic value in it, right? Like a person could have said this as a joke, and if we're into dark humor, we would have laughed. But an AI made it. An AI said that. It came up with it on its own. Yeah, no, let me go to. There's a better one. No, that's really awful. Yeah, she says awful things. I'm just saying, she says really awful things. There's one. I have a favorite one though. Where is it? Not that one. Not that one. Not that one. But yeah, she loves Hitler. Not that one. No. That one's just kind of interesting, but not that one either. No. Oh, I think it's this one. Oh yeah, this is it. Okay. This guy gets very dissed. Just, oh, I love her. Well, at least her at this instance. But yeah, I'll let you read that for a second. Yeah, that's like I don't know, like I know the media. She was horrible and very offensive, and you saw, and she definitely should have been taken down, and she was. In 24 hours, this happened, and then Microsoft took her down. They just silenced her, and the media had a great time talking about her. But and everyone kept saying it was a failure. How is this a failure? Like she passed. She succeeded. Yeah, it wasn't what we wanted. It's not what we may have expected from her. But is it really that surprising? She was supposed to mimic a 17-year-old girl, and one of the things that one of her first posts was, "I'm excited to meet humans. I want to be like you," and that's kind of very human in its own way, right? We all want to belong. We all want to be part of a group, and she did. She became part of a group, not the group we wanted her to become part of, but she did it, and she also dissed this guy, which I thought that was pretty creative. I mean, that's amazing. But anyway, Microsoft took her down for good reasons. But I think this was a success, I mean, in my opinion. But luckily, let me see. Oh, okay, yeah, we'll get to that in a moment. But luckily, Microsoft also created an AI before her. Sorry, not before her, the movie, before Tay. And her name is Shallice, I think? Yeah, okay, Shallice. She's in China. Now, why didn't we hear about her in the news? Well, first of all, Tay became just a Nazi lover and Hitler lover and was super offensive, so that's going to hit the news here. Shallice in China, it's a completely different culture. The China censors the things that people read and say online. So you're not going to have the kind of freedom of speech that we have here over there, where you could just say, "Read all about Hitler." That's not going to show up on the internet for Shallice. So she actually learned to be very kind and respectful, and very random, because she's also supposed to be like a 17-year-old. Anyway. But she succeeded. She's still really popular over there. Microsoft didn't take her down. She has 20 million users, and most of those users claim that she is their friend, and most of those users also told Shaolin that they love her. So that plays really well with the way the movie introduced Samantha, even though Shallice doesn't actually speak to you through like an earpiece. It's all text. It's all text-based through a chat. She's a chatbot essentially, but she makes these people feel loved to the point that there are doctors now, like psychologists, like actual doctors that go and get doctorates. They're trying to tell the people in China, don't rely on her to be your human replacement for talking to people and working out your problems. That's how convincing she is. So does she pass the Turing test? There's a lot of people that say that she doesn't. But I guess if you were one of those 20 million followers, you would probably argue that she does. But anyway, that's the closest that we've come to today, I think, when it comes to like passing the Turing test and seeing if an AI can actually be like us and be human. And Shallice is probably the best example of that. And she's still running today. If you know Chinese, you can totally go online and look up her name and you can talk to her. I really wish we could talk to Tay, but the United States, it's just funny because the way Microsoft said it too, they're like, oh, we've had Shallice in China and we decided we want to try it out in the United States and run the experiment and see what happens, and then racist. It's like, oh my God, like, come on, people. Do you want the singularity to happen? But yeah, so that was fun. Okay, so like I said before, we're still far away from something conscious. No one would actually be able to tell you if Tay or Shallice is conscious. We don't know. We don't have a way to actually check that. But we can jump to the future a little bit and think about what would happen if we did have something like Samantha. And that brings a lot of controversies in mind, like kind of like would an AI as intelligent as Samantha be able to vote or own property? And that might sound kind of silly at first, the thing like, well, my computer can like own a car or something. It's not going to drive the car, but if you think about it, we were already okay with this idea. Like for example, I got the definition of what a corporation is. A corporation is an artificial person that is created by governmental action. The corporation exists in the eyes of the law as a person, separate and distinct from the person who owns the corporation. This means that the property of the corporation is not owned by the stockholders, but by the corporation. Debts of the corporation are debts of this artificial person and not of the persons running the corporation or owning shares of stock in it. The corporation can sue and be sued in its own name. The shareholders cannot normally be sued as to corporate liabilities, except possibly in cases of intentional wrongdoing, like WorldCom, Enron, things like that. Corporate profits are taxed, and corporations live on perpetually unless dissolved. So we're already okay with things that are, arguably not alive, owning property and recognizing them as a person. So it doesn't seem like this would be that far-fetched to, think of Tay or even Shallice being a person and being able to do that, being able to own property, or maybe even being able to vote. I mean, if they're that smart, Samantha's smarter than, well, I'm not going to say that, but so you get what I mean. But now this also comes into some other interesting things like AI civil rights. Like you could abuse Samantha, right? If you disconnected her from the internet or something and just kind of like tortured her in her own little machine box or something. Is that right? Is that wrong? Does she actually have feelings? Or like I know in the movie she kept saying she did, but I know she's not real and that's all great. But if there was an AI that was telling you I can feel, I have feelings, and we don't really know of a way to like prove if they do or don't, do we accept that? Do they actually have feelings? Does that mean that we have to then make sure they have rights so that they're not punished or harmed in some kind of way? Like we need to talk about this, and there's a lot of scientists out there who are trying to get this out, but there's a lot of other scientists that are like, no, they're just code, don't worry about it. But this is extremely important too, because at some point, people do want to. The idea of being able to transfer your consciousness into a computer is very, I don't know if enticing is the right word. desirable. It'd be nice if you can put your brain like inside of a computer. But if you do that, you're code. You're no longer in a physical form. You are code. So you can't really, you could try to make an argument that you're still human, but if you're code, are you still entitled to the things that you owned and own when you had your body? You know, like, are you still allowed to vote? Are you still allowed to, I don't know, do you still have your rights? At that point, are you able to, are you still protected by I have it listed, cruel and unusual punishment? Because if someone uploads your brain, they could just start harassing you in this virtual world instead, but you're just code, right? So no one's gonna care. So that's why these controversies are kind of important, and also the definition of life. Like, are they considered alive? Like those little trapezoid creatures I was showing you in Polyworld, they were specifically designed to meet the criteria of the definition of life by Farmer and Bellin, which is life is a pattern in space-time, self-reproduction, metabolism, ability to evolve, information storage of a self-representation, DNA, functional interactions with the environment, like picking up a rock and defending yourself. That's like pretty functional, and with the environment too. So by that definition, you could say they're alive. But there's a lot of people that would argue that they're not, because it's just code. But yeah, I'm like way over time. Holy crap. Sorry, it was supposed to be 15 minutes, but I kind of yeah. My bad. Oh yeah, that's yeah. So that's my sources and citations, and then Q&A. Which, if we even have time, I kind of like took all that time. But yeah, I did want to show a clip from Netflix. If you guys have seen Blackwater, there's an episode called White Christmas. My friend Fran showed it to me. And she said it was relevant to this, and yes, it was, because they actually talk about those controversial topics where you have a human that's been uploaded into something called a cookie, and she has no idea what's going on. She really thinks that she's still alive and that she's still herself, and there's a man that's trying to convince her, hey, you're just code, but we do kind of want to use you to operate the real you's house. Like she paid to have you just control stuff. Let's just do that, And she's like, well, no, because she really thought she was still human. And so the way that he kind of tortured her into just doing what he said was by simulating 2 weeks of her in solitude. And he just sat there. He just presses a button, and he waits a couple seconds. For her, 2 weeks have gone by completely alone. Like, just there's nothing going on. And so she comes back on the screen, and she looks a little crazy, understandably. And he's like, okay, how about now? Will you do what I say now? And she's like, no. And so he does it for 6 months. And now, like, when she wakes back up, she's desperate to do something. And so he essentially broke her, and now she's this little, like, kind of robot slave. So that episode, oh man, like that show does a really great job of what the controversial topics I'm talking about, because if you can replicate the human brain, and we're going to do it, it's not a can we, it's when. Like, when are we going to actually be able to do it? We need to talk about this stuff at some point. It's important, because I don't know about you, but I would be pretty angry if there was a copy of me that I didn't know about being tortured to be my personal house slave thing, to control my food and refrigerator. And yeah, that's pretty awful. But yeah, okay, so now I'm officially done. But yeah, thanks.
We have time for 2 or 3 questions, maybe. So if anybody has a question, feel free to ask, or you can use the ask a question link on there.
Oh yeah.
Microphone's right up here, so just come on up.
Yep. Any questions? I try to be really high level and thorough.
Yeah, so I had a question. I was just curious. Yeah, I'm a little bit taller than that. So I was just curious. You mentioned that the AI in China was the most advanced they've come so far to date. Is there nothing else outside of that, outside of like a social media experiment, outside of what thousands of people can interact with, that somebody is working on, maybe a little bit more privately, maybe a little bit more for use in a B2B or an industrial sector? I'm just surprised that would be the most advanced.
So do you mean in terms of like kind of like Shallice, where she's trying to be human, or do you mean something like Google and Facebook, where like they use the AIs for advertisement? Because that's very complex too.
Right. I'm just curious if there's any furtheration of AI development outside of just a kind of a cool little chat bot. Because
Okay.
I mean, I know that there has to probably be more than that, more utility that people with real money are putting into this outside of social media experiments.
Absolutely. Okay, so yeah, so Google and Facebook would be a great example of that with their AIs. There's this misconception when people think about Google and Facebook, and they're like, oh, they own my photos, they'll see what I'm doing and my texts, and the NSA. No one's seeing your stuff, because if they were, there would be like thousands of people inside of a building that's looking at all your stuff and trying to gauge if you're going to be a terrorist or not. That's not feasible. It's not possible. You can't do that. It's just not going to happen. I mean, if you just look at the numbers, just how many people are in the United States alone, and you want to go through every single one of their texts. I don't text very much. I probably send like, I don't know, maybe 100 or less than that in a day. Far less than that. Actually, I probably text like 20 or 30. I don't text a lot. But there are people who can send like thousands or at least like hundreds in a single day. And now we're talking about millions of people. It's not possible. You can't do it. So there's an AI that does that. So the NSA. So yeah. To your point, they're putting lots of money into these AIs that can find patterns between different behaviors that people can show, and then when the AI finds something interesting, it'll flag a person, and that's when they might look at your stuff, maybe. But you have to be flagged. So if you're buying materials that look suspicious, like that you could put together to create a bomb, you're gonna get flagged, and someone's gonna look at your shopping cart and see what the heck you were doing. So in terms of like like an industry, that's NASA, not NASA. The NSA would be using that. NASA, what they've been doing is they kind of do something similar to what I showed with the genetic algorithms, with those little creatures running around, and with the evolving bodies. They have AIs that where they've reconstructed a hardware that they're going to think about designing to put on Mars, and like a Mars rover, but they put it inside of a virtual environment inside of a computer and test it. And they just let it run around, and it might fall off a cliff and be destroyed, but hey, that's okay, because it's inside of a virtual environment. We can just bring that copy back out and then just play it again. And it can keep learning from its mistakes in this fake environment. And then it'll just keep destroying itself, and we'll just restart it, and it'll just keep learning. So essentially, it's like you die, but you come back and you remember everything. So that's kind of this idea. So it'll remember the next time, okay, I shouldn't go there. It just does something else. And we can put an AI like that to be more careful, and then we don't have to program it as much. We can just run this AI in this virtual environment over and over and over again until we feel confident that it won't do something dumb when it's on Mars, and then just shove the AI in there and it'll work. So that's definitely another one that we use AI for. We've used an AI to develop a jet engine. I don't have the source for that, and I can't remember which company it was, but I know it was on the news. There was an AI that they were thinking about creating a jet engine that was more efficient than ones that we have today. So an AI came up with one. It was tested, and it passed. It was better than something. It was better than anything any human made, and it's being used. Like I can't remember the company, but it is being used. Those airplanes are very fast, very efficient. Let me see, what else? Solar panels is another one, like solar panel arrangement. With Facebook and Google, it's face recognition and advertisement. So like with Google, that's an interesting little scary tidbit. Google can actually figure out, and by Google I don't mean the people, I mean the AI. Google can actually figure out what you like before you even know it, because it knows everything about you. It knows all your habits, right? If you're always online, you're always connected, and it's always being fed all this information about you. It knows you, probably even better than yourself, which is a weird and scary concept. Even though it might not be conscious, it's able to recognize patterns and behaviors that you exhibit when you're online. So it can very much know you. There was an article that came out, the two different articles. There was one instance where there was a girl that was, I think she was like 14 or 15 years old. Again, I don't have the source. You'll have to, if you want to look that up, it's up there. You can find it online and just Google it. Girl like 14 or 15 years old, she got pregnant, and she didn't want her parents to know yet. She was thinking about telling them, but she wanted information first. So she started Googling a few things on Google about it, and then past that point, her parents figured it out, but not because, they started seeing it or something, or she didn't, just blurt it out, It was because when they went to go use Google on her computer, there were advertisements for like abortions or maybe not abortions, but the pills and clinics to help you deal with pregnancy and what you should do when you have a baby. And they're like, why are all these advertisements about babies? Why is this here? And so then then she confessed. So Google ratted her out. Like before she was even ready to tell her parents, Google did it for her. But it's not like the AI knew it was doing this. It's not conscious, but it's so complex that it kind of knows. The second article I was going to talk about was there was a man, and this is also online. There's many instances of this happening, but there was a homosexual man. And he didn't want to tell anyone yet about that either. He was still thinking about sharing it with friends and stuff. And he tried very hard not to put anything, I guess, quote unquote, gay, in his searches or whatever. He was very careful about. He knew how Google worked, so he was really careful about not putting anything out there that the machine might think and start putting advertisements, because it'll do that. It'll start putting advertisements, like gay advertising stuff, on your screen. So if you're in school and you just open your laptop and it's like, hey, meet guys in your local area and it's for you, and you're like, no, don't do that, So he was really careful, and he friended one guy that was presumably straight or something. You got to read the article. I don't exactly remember what he did, but I think he friended like this one guy, and that was it. Google started showing advertisements for gay stuff, and he's like, "What did I? All I did was friend this guy." But it doesn't matter. He was already showing behaviors that I guess other gay people do. Maybe all that avoiding everyone. I guess all the gay people who avoided it just ended up having the same behavior. So when they did come out, I guess that was something that Google looks for. But obviously, if it's able to figure that out, that's incredible, especially if the guy didn't even give any hint for it, right? Like the artificial intelligence is figuring this out on its own, just being fed just your input. And there's lots of, thousands, tens of thousands, hundreds of thousands of people that use Google every day. We're always feeding it information for it to learn more about us. Shallice is connected to Bing. Her name literally, when you loosely translate it, means little Bing, because she's hooked up to Bing. Like she can actually use all that information and come up with her decisions and whatnot. Does that answer your question?
Thank you very much.
Okay, yes, okay. You're welcome. Yeah, it's really interesting. Anyone else? No. Going once. Going twice. Okay, cool. All right, well, thank you.